Our first unit here is going to be about systems of equations, which is something you guys should cover in Algebra 1. So I'm hoping a lot of this is review today. There are some graphs on here that that you'll see in a second that you would not need to know how to graph right now, but we're just going to use them for purposes of illustrating some of these examples. So I'm going to start here at the top. I already wrote these definitions, so you don't have to write anything at the top. This is just for you to read. In general, though, system of equations, we're just going to kind of start here with two equations with two variables, but it could be three equations with three variables or bigger than that. So this just says a set of two or more equations that use the same variables. Okay, now our goal here is going to be finding solutions to systems today. We're going to use graphing to do that, but there are algebraic methods. But this just says, in general, solution for your system is going to be a set of values for your variables, usually x and y when we do these, that make all the equations in the system true. For our purposes today, it says you can solve systems by graphing. That's what we're going to do. And what you're looking for on a graph is what it says right here. The points where the graphs intersect in the coordinate plane would be solutions if you're solving by graphing. So we're just going to start with a system that just has two lines. Let's see if you guys remember how to graph a line. Okay, so let's see. I'm just going to grab two different colors, hopefully, so we can see these okay. All right, so I have two different equations in the system. They have the same variables, x and y. They're both in slope-intercept form. So can anybody, just raise your hand, do you remember if I asked you to graph y equals 1/2 x plus 3, like where would you start at? How would you find another point? Yeah.
3.
Okay, 3 where? Good. Okay, now do this. You don't have to do this for me, but I had so many people this morning, they started on the x-axis for their y-intercept on accident. So if you're in slope-intercept form, whatever, this one's 3, you want to make sure you start on that vertical axis. So we're going to start at 3. Okay, now how would I find another point? Perfect. That number in front of the x, that's your slope. So you just go 1/2. This is your rise over run. So the top number tells you to go up or down. The bottom number is going to tell you to go to the right. So this is +1, and then I go over 2. Okay, now if I was just graphing this line, I would just play connect the dots. But if I'm solving a system, I'm just going to put a couple points on here. And ultimately, we're going to see if this runs into the other line, where I'm going to draw that in a second. But I'm just going to leave that go for a minute. So just draw a couple points so you can kind of see how the line goes. Okay, now, how would you graph the second equation in the system? That's -1/4 x minus 3. Where would you start that? And then this one has a negative slope, so how would you find another point? Like, where would you start it at on the y-axis? What do you think? Okay. Yeah, good. All right, now, how would you find another point? Okay, now, this is tricky. Okay, if you go down, is that a positive or negative direction? Like going down, positive or negative? Negative, right? Okay. If I go left, is that positive or negative? Negative. If you go down, negative, left, also negative, that would make a positive. That always throws people off. Okay, so if I got a negative slope here, here's my best recommendation to you. I always attach the negative to the rise part. I just do it with the top number. If you got a negative slope, you want to go down, but then go to the right. So that'll be a negative direction. So I'm going to go down 1 and then over 4 to the right. If you have a positive slope, just go up and right, and that'll be correct every time. Now, in this case, you can always go a different direction to kind of back it up if you need to, which is what I'm going to kind of want to do here. So I'm just going to lay my pen. Here's that first equation. Here's that second equation. And I can see they're going to intersect back here. So I got to kind of back up both of these slopes. So for this one, if I go down 1, left 2, that's 2 negative directions. So that's actually a positive slope. So I'm just going backwards. I'm just backing this up. This down 1 over 2, just do that for a couple of points. And if I want to make a negative slope go backwards, you actually go up, which would be a positive direction, and left, which is your negative direction. So I'm going to go up 1, 4 to the left, up 1, 4 to the left. Ultimately, all we're trying to see is if and where these lines have a point in common. And so they do. and that is going to be the solution for our system. So ultimately, I'm looking for that point where they run into each other. If I'm asking you to solve something by graphing, it's not going to be on a nasty point. It will be exactly on one of the grid marks. Otherwise, we would use algebra to solve that, because there's better ways to do it if it's not an exact point. So if you're being asked to graph, it should be an exact point if it exists. So this would be, let's see, we're going -8, -1 is the point that those two lines are going to have in common. So that would be the solution for my system. If you plug in -8 for x and -1 for y, it would make both sides of both of those equations true. Is anybody having a question? Okay. Now, I'm going to give you systems down here. I'm just going to ask you to graph lines today. You shouldn't have to graph anything else. So these have part of the system provided for you on the graph. So this first one here, part B, it says the first equation in the system is graphed for you. So the parabola here, that's x squared minus 4x plus 6. We'll graph those later in the semester, but for the moment, you guys don't have to graph anything like that. So I'll put that on the grid for you. So we want to see if that has any points in common with the line here, which is y equals x plus 2. How would you graph the line y equals x plus 2? Perfect. If you just have a plain x, it just has a slope of 1. So if you want to think about that as 1 over 1, just going to go up 1 over 1 to the right. So we'll start on 2. Make sure, please, and you don't have to highlight this or anything, but I'm just doing it because I had so many people have problems today. You got to start, that y-intercept goes on the y-axis. Don't put it on the x-axis because it won't give you the right answer. So you're just going to start at 2 and just up 1 over 1, up 1 over 1. And how many solutions do you guys think this system has? There's actually, this is interesting. So it actually runs into the parabola in 2 different spots. So you can have that happen. So I actually have 2 different solutions to this system here. So if that's the case, if they share 2 points, you just write them both down. So what do I got here? It looks like 1, 3, and also 4, 6. Oh, sorry, I'm not on the screen. Fail. Shut up. So this one actually has 2 places they run into each other. All right, now, next to this, the first equation in that system that's written there, x squared plus y squared equals 25, that's actually the equation of the circle that you see pictured there. So you don't have to graph that. I just want to see if this line, which I have as y equals -x minus 1, does that line have any points in common with that circle? So if I was graphing that line, where would you start y equals -x minus 1? Where would you start at? What do you think? Yep, perfect. Okay, now, my slope here, it's just like a little negative sign in front of an x, so that would be -1. How would I find another point? Go ahead. Perfect. Okay, we're going to go, if it's negative, just go down and right. So I'm just going to go down 1, over 1 to the right. Down 1, over 1 to the right. If you have a negative slope, it should go down from left to right. If you have a positive slope, it should go up from left to right. Now, I'm going to also back this up, because if I lay my pen here to kind of extend the line, I can see that that's going to run into that circle in another spot. So I'm actually going to go backwards to get that other spot. So I'm going to go up 1 and left 1. Up and left. The up is a positive direction, but the left is a negative. So that way we keep our negative slope. So really what I'm interested in, where does that line run into that lovely circle there? And that's all you're looking for. So just these 2, it intersects it in 2 different points. So this one, just kind of like the last question, there's actually 2 solutions here. So looks like -4, 3, and +3, -4. Is anybody having a question? You should not have to graph anything except a line today. So don't worry about graphing parabolas or circles. If something like that's on an assignment, it'll be graphed for you. Okay, now I'm going to give you a couple here at the top. So these guys are not both in slope-intercept form like they were on the front. One of the equations is and one of the equations is not. So let me just graph the very first equation in this system, and then we'll talk about maybe what we want to do to tackle the second one. So if I've got y equals negative 2x minus 1, just don't forget, we always want to make sure, start yourself on the y-axis. Don't start on the x-axis on accident. I had a ton of people doing that. So just find negative 1. And my slope there is negative 2 over 1. So what I want to do, I'm going to go down 2 and 1 to the right. I'm just going to do that couple, 1, 2, 1 to the right. All right. Now, if you don't have slope-intercept form, which I don't here, forgive me, I'm just going to rewrite this down here. My other equation is 2x plus y equals 5. So if I'm asking you to graph, that's just another equation of a line. What might be something you would do to help you graph that? We could do that. I might do one thing that might make it just a teeny tiny bit faster. Maybe. It's just going to save you a step. If I get y by itself on one side, it'll make it in slope-intercept form automatically. This will just save you one step. So if I just subtract the 2x, you could subtract the y, but it's just going to cause you to do a little bit more work. So I'm just going to do that. Now here's my best recommendation to you. If you have a term with the x, put it right after the equal sign. All right, so we subtract the 2x. You can't combine that with the 5. Just write that negative 2x right after the equal sign and then slide the 5 over. Okay, so the 5 is just going to be plus 5 because that's positive. Okay. Now, this guy is really the equation of the second line we've got in that system. It's just in slope-intercept form, so this makes it way easier for us to graph. Okay, so I would start that guy at 5, right? And my slope for this one is negative 2, so I'm going to go down 2 over 1, down 2 over 1. What can you guys tell me about solution or solutions for this system if you're looking at this? No solution. Okay, because they are parallel. All right, if you have the same slope, which I do here, they're both negative 2, and my y-intercepts are different though. One y-intercept here was negative 1, the other one was 5. These are parallel lines, so I'm just going to write these are parallel, so there's no solution. They would never run into each other. Is anybody having a question about that? Okay. Now, algebraically, if you can kind of figure that out, if you go through there, like maybe I just know that if I have the same slope and different y-intercepts, then I know they're not going to intersect. If you don't want to graph that because you can say to me, hey, I know these are going to be parallel, as long as you could explain it, that's fine with me. I just wanted you to visually see it on the graph too. Sorry guys, my eye's watering. Okay, let's try one more here. So the first equation, it's in slope-intercept form, so that's nice for us. So I'm just going to start at 3 on my lovely y-axis. And our slope here is negative 1/3. Again, I would just attach the negative to the top number. So I'm going to go down 1 and 3 to the right. That bottom number is how you're going to go right or left. So I'm just going to go down 1 and 3 to the right. Okay. Now, if your other equation is not in slope-intercept form, the easiest thing I can tell you to do to put it in slope-intercept form is just get y by itself on one side. So if I'm looking at this equation where I have negative 2x minus 6y equals negative 18, and I was going to try to get y by itself on one side, what would you do first? If you were going to try to get y alone on one side, what do you think? You can do that. If you do, though, you have to do it to all the terms in the entire thing. You'd have to do, so I might do one quick thing before, I'm going to do that, but I might do one quick thing first. Yeah, let's move this just real quick. This is negative 2x. I'm going to add this to the other side. Okay, now again, just recommendation. If you move the x to the other side, I'm just going to write that immediately after the equal sign because that'll make it look more like slope-intercept form, and just kind of slide that negative 18 down. And then this will make it just a little easier. Just divide everybody by negative 6, exactly like you just said. Okay, now the y will be alone then. What? My slope is going to be that 2 over negative 6. Can we reduce 2 over negative 6? What would it be? 1/3, right? But it's going to be, the 2 is positive, the 6 negative, so I'm just going to write that as negative 1/3 x. Now, what do I get if I do negative 18 divided by negative 6? Positive 3. Okay, now, what do you all notice about that and the first equation in that system? These actually algebraically, once we solve that, they end up being exactly the same. So this would literally be like 2 lines graphed right on top of each other because these end up being the same line. If that's the case in a system, if both the equations end up being the same line, do you guys know how many solutions or what the solution would be for that? Infinite, because they have literally every single point in common. So if you do end up with the same line, this is infinite solutions. And I usually just put the infinity symbol so I don't have to write that out. So that's infinite solutions if you got the same line. That wasn't obvious to me when I started the problem. Once I got that second equation in slope-intercept form, it was easier for me to compare them, and then you can see they end up being the same. Okay, now, I have one question like this on the homework, and you don't have to graph anything for this problem. So what this example 3 says is related to what we've been doing. This says, is 4 to the point a solution to the system that's provided there? Okay. Without maybe using a different method that you might know to solve that system, how could I just determine, if they give me a point, how could I use that point to determine if it's a solution to the system? Like, what could I do with 4, 2 to maybe decide if this would work as a solution? What do you think? Good. Perfect. Okay, all you're going to do is plug in 4, 2, but you're just going to do it for both equations. Okay, if it makes both of the equations true, then it's a solution. If it doesn't make both of them true, then it's not a solution. So all I'm going to do, remember that first number is the x-coordinate, the second number is the y-coordinate. So 4, 2, what I would do, everywhere I see an x in that first equation there, I'm just going to replace it with a 4. So it would be 4 plus 2 times the y-coordinate, which actually is 2. And then that equation is equal to 8. So you're basically just going to tell me, like, is this a true statement if I plug it in? So if I take 4 plus 2 times 2 would also be 4, and I'm seeing, is that equal to 8? Well, for sure, we're going to get 8 equals 8. So it is a solution to that equation. But for it to be a solution to the system, it has to work for both. Okay, so you just have to plug it in one more time, and it has to work for both of these. So the other equation was this 2x minus y equals 6. So same thing, everywhere I see an x, I'm going to replace it with the x-coordinate of that point, which is 4. Everywhere I see a y, I'm going to replace it with the y-coordinate of that point, which is 2. So I'm going to end up with here 8 minus 2. We're seeing if that's equal to 6. For sure, this is 6 equals 6. And so if it works for both, then it is a solution to the system. So I would write yes there. If one of those was not true, then you would say no. If both of them are not true, you would say no. It has to work for both. Okay, anybody have a question? Okay, now I'm just going to slide down. I just got a couple special cases down here to see if you guys remember how to graph lines that might not quite be in what you guys would think of as slope-intercept form. So, do we know how to graph? These are lines, I promise, in part A and part B. I just literally have y equals just the number 8. So no x there, just y equals 8. Do you guys know how to put that line on the graph? You're so close. You're so close. Say that one more time. I think you're saying that right, but I don't know. I'm gonna. Okay, let me have you guys do this. Okay, I know you're saying it right, but I'm not thinking about how to explain it correctly. Think of a point where the y-coordinate is 8. Just any point on this graph where the y-coordinate is 8, right? Most people would point me like right here, right? So that would be the point 0, 8. Okay, now this trips people up. So think of another place where the y-coordinate is 8. would you, if you went down, right, this would be 0, 7. So that's not involving an 8. If I go here, though, like this is the place 1, 8. This would be 2, 8, and 3, 8. So it actually goes across horizontally. It throws people off every time. Okay, just to remember this, and you don't have to use this if you don't want to, but it's because it's parallel to the x-axis. I think that throws people off. This is the equation y equals 8. I call it horizontal to remember it because I always get that backwards because you think y-axis, you immediately, most people are like, oh, that's vertical, which the y-axis is vertical, but it's not the equation if you have y equals a number. Any y equals a plane number is going to be a nice horizontal line just straight across. And then with the x, it's kind of similar. It's like you would think it would be left and right because the x-axis is up and right, or left and right, but it's actually backwards from that. So I'm like, okay, let me find a place where the x-coordinate's -3. So most people would go to the -3 on the x-axis, right? Now think of another place where that x-coordinate's -3. That's your only requirement. The x-coordinate has to be -3. If I go to the right or left of that, the coordinates would be -2, 0, or -4, 0. So those aren't involving a -3. You have to go up or down. So like -3, 1, -3, 2. So anytime you have an x equals just a plain number as a line, it's going to be a vertical line. And if you want to use this, feel free. Call this vertexal to remember it. So I call it horizontal and vertexal. I literally learned that in 9th grade and I still say that to this day, and I won't tell you how old I am, but it's been a long time. So this is x equals -3. X equals is going to be a vertical line. Y equals just a plain number is going to be a horizontal line. Then if I'm trying to find my solution to the system, it's just that point right there that they have in common. So the x coordinate's -3. Y coordinate has to be 8. Okay. Now, if I graphed this next one, x equals 0 and x equals 5, could you tell me the solution without graphing it? This one would be no solution. Okay, these guys would be parallel because they would be two different places. So x equals 0. I know this is super weird. X equals 0 is actually the y-axis. So x equals 0, all the x coordinates are 0 as you go up and down the y-axis. The y values change, but the x values are all 0. So x equals 0 is actually the equation of the y-axis. And then if I did x is 5, just a nice vertexal line through all the x values that are 5. So up and down there. So those guys would be parallel to each other. So this one would be no solution. Is anybody having a question? Okay, now I'm going to have you graph. I've got x equals -2. So if it's just x equals a number, just go to the x-axis, find that number, -2, and we're just going to draw a vertical line up and down right through that. All those x values are -2. The y-coordinate changes as you go up and down, but all the x-coordinates on that vertical line will be exactly the same, so -2. The x value, I know if I have an intersection here, has to be -2. Now, the other equation, this is more similar to what we were doing on the front. Just grab your, this is in slope-intercept form, so I'm going to start this at 4, make sure you're on the y-axis, and then I'm going to go up 1, 2, 3, 4, 5, and over 2. Now, that's not going to get me towards the direction I want to go, so I actually want to go backwards here. So I'm going to go down 1, 2, 3, 4, 5, and then I'm going to go to the left 2 to actually find where that intersection would be. So sometimes you might have to back it up to figure out the solution to your system, but you're just trying to figure out the point that those two lines have in common to get your answer. This guy looks like -2, -1. So just one solution there. And then I've got one more. I've got a parabola. So that first equation is the x squared plus 2x minus 4. That's graphed there for you. And then the other equation that we're going to put on here, y equals -6. So on the front, we had a line and a parabola, and there were two solutions. Anytime you have y equals a number, it's going to be a nice horizontal line. So find that -6 on the y-axis and just draw a horizontal line right through it on either side, left and right. What would you guys tell me for the solution to that system? None. The parabola and that line don't end up touching. There's no way they'd ever intersect, so this actually has no solution here. Okay. Is anybody having a question so far about anything? All right.